Hello, good afternoon. Uh, Today, let's do a Doppler effect. So, I have a question here. The graph below shows the relationship between the apparent frequency, which is the frequency of a listener, and the listener is stationary, and the velocity of a source, or the speed of the source that is moving towards the listener. So as you can see the graph, this is the frequency of the listener and this is the speed of a source. So as you can see the graph is going up. It means that as the car is moving towards the listener, the frequency of the listener is increasing. So the question says use the information in the graph to calculate the speed of sound in air. So let's say we know the formula of the Doppler effect or the Doppler effect equation. The frequency of a listener is equal to the speed of sound in air plus or minus the speed of a listener So this is the frequency of the listener, this is the speed of sound in air, and this is the speed of a listener, the speed of sound in air, and the speed of the source. And then we multiply by the frequency of the source. So since they said our listener here is stationary, but the source is moving towards the listener, it means that if the source is moving towards the listener, that means the frequency of the listener will be greater than the frequency of the source. But if both the source and the listener are stationary, it means that the frequency of the source will be equal to the frequency of the listener. So if the source is moving away from the listener, that means the frequency of the source will be greater than the frequency of the listener. But since this one is moving towards, so since it's moving towards, it means that our formula will be like this: towards plus or positive up, and then negative down, just like that. So this is the formula for moving towards the listener. Now, from the graph, let's say we start from 800. This is the frequency of the listener. We don't have the frequency of the source, we only have the frequency of the listener. Now let's start here. Let's say we take 800. We want to make equation 1. We take 800 as the frequency of the listener first. So let's say this is our frequency of the listener is equal to V. Since the question said you calculate the speed of sound in air, so plus the listener is stationary all over minus. Now, what is the speed of a source? Since we took 800, it means that the speed of a source is 0. So 0. We don't have the frequency of the source. Now, what is this? This one is going to give us 1. Since 0, V plus 0 is V, V minus 0 is V, V divided by V is 1, Fs. It means that the frequency of the source is equal to 800 now. Hertz. So let's say this is our equation 1 there. Now let's move. Let's say now want to make equation 2. Still, the source is moving towards the listener. Now, let's choose another point. Since we deal with the gradient, let's choose another point. Let's say now we take 850 as our second point now. Since we take 850, it goes with what? With 20 meters per second as the speed of a source. So we're going to say 850 is the frequency of the listener. This one is 0. This one, now let's check. It's 800 with what? With 20. So the speed of the source is 20 now from the graph. Then Fs. But what is Fs? Let's say this is equation 2. Now we substitute. Let's say we substitute equation 1 into equation 2. Now let's check. 850 as in equation 2 is equal to v plus 0, which is v, all over v minus 20. What is Fs? Fs from the equation 1 is 800. So we're going to substitute 800 here. Now let's see, we divide both sides by 800. We divide by 800. So we're going to have 1,0625 is equal to v all over v minus 20. So let's say now we cross multiply this times that, this times that. So v is equal to 1,0625 v, which is this times that, minus, we're going to have 21,25. So it's 1.0625 multiplied by 20. That gives us 21,25. So we group the like terms now. V minus 1,0625 v is equal to negative 21,25. So this one is going to give us obvious 1 minus that. It will be 0, which is a negative 0.625 v is equal to negative 21,25. Then we divide by the coefficient of v. We're looking for v 25, negative 0.0625. Then v will be equal to 340 meters per second. So it means that the speed of sound in air as the source is moving towards the listener is 340 meters per second. So let's move to the following question. Now the following question says, now you approach a stationary source. You as the listener or as the observer, you are moving towards the stationary source with a speed such that the frequency of the sound you hear is 13% greater than the actual frequency. So it means that the frequency that we hear, it should be 13% greater or more than the actual frequency that is being emitted by the source. So now, with what speed are you approaching the source or the sound source? So you take the speed of sound in air as 240 meters per second. So they are saying the frequency of the listener as the frequency that you are detecting as you are moving towards the stationary source will be greater. So it will be greater than the frequency of the source or the frequency that is being emitted by the source. It will be 13% greater. That means what? 13%. We divide by 100 always, percentage. So it means that the frequency that you are detecting, is what? Is greater or is 13% greater than this. That means it's this plus the 13% of that. So it's going to be the frequency of a source, so plus this one will be 0.13 Fs. So it means that we're going to have 1.13 fs as the frequency of the source. I mean, as the frequency of the listener. So the frequency of the listener is 13% greater than that. That's what they are saying. Now, they are saying, with what speed are you approaching the sound source? As we take the speed of sound in air as at 340 meters per second. So now we are going to our equation. Is equal to V plus or minus VL, V plus or minus Vs. So now, since you as the listener, you are moving towards the sound source, it means that as we know that the towards is positive up there and the negative down there. So now we move. What is the frequency of the listener now? So the frequency of the listener is this one. So the frequency of the listener is 1,13 fs, as we can see from the equation 1. This is the frequency of the listener now. Is equal to, they said the speed of sound in air is 340 meters per second, plus, we don't know this one, 340 minus 0, since they said the source is stationary. Now, what is this? This one, it will remain like that, fs. So now, let's say we divide the whole equation by fs. So fs will divide fs, this one will cancel that one. Now we're left with 1.13 is equal to 340 VL all over 340. So now let's say we cross multiply now. So when we cross multiply, this side will be left with 340 plus VL as this one is equal to 340 multiply by 1,13, which is that one. So 340 plus VL is equal to 340 multiplied by 1,13 is going to give us 384,2. Then we take 340 to the other side. VL is equal to 384,2 minus 340. And then this multiply minus that is going to be 44,20 meters per second. Remember, 2 decimal places. You round off the final answer to 2 decimal places. As you can see, it's 20. It's not just 2. So this is the speed that you are approaching the stationary source, since they said the frequency that you are detecting is 13% greater than the frequency of the source. So this is the speed that you are moving with towards the stationary source.